Collabnix community for organizing OSCONF. I've been trying to, submit or speak at OSCONF for quite some time, and I was not able to do that. And this time I think somehow like saw that on paper call, and then I submitted a talk and gladly accepted. I'm really glad to have here, and thanks entire community, Ajit, and all the people who are coordinating. And I would really be excited to speak at this one. So I'll share my screen to start with, and then we can get going. Okay. So can you see my screen already? Harshita?
Yes, we can see.
Yeah, great. So, so specifically, this talk is about deploying Elastic Stack on Kubernetes. How do we do it? What are the things that we have? I believe you might be talking about a lot of things like, containers, Kubernetes, like orchestration or various other things. I've seen Argo CD, specific information on that, and then like I think some other talks on application development as well. So what I'm going to talk about is like I'll skip, if the time permits, we will cover most of it, but otherwise I'll skip general knowledge and then move over to whatever I want to cover. But to get started, today I'm using the Google Kubernetes engine because cloud is something that now everyone is using and for everyday use cases as well. So I'm just gonna demonstrate everything on cloud itself. So so in the interest of time, what I'm gonna do is like spin up a cluster, go back to the session and do some slides, and then we'll come back and do the demo on this thing. By this time the cluster would be ready. So I'm gonna put my name. Okay, and because I think we are in India, and then I could choose AP South A. Probably this is Mumbai, I believe. And then we could use this one. So I'm just gonna create this cluster. I'm not gonna choose anything else, and then just click on create. This is GKE, as you know, Google Kubernetes Engine, which is a flavor of Kubernetes that is an open source project, right? So we'll get back to it. Let it run, and then we'll come back and we'll look into all of this. Now let me present. Great. So before, I think Harshita has given a great information about myself, but I'm Arvind and I work as a developer advocate. And then I used to run, DigitalOcean cloud community in Bangalore previously. And then that's how I started doing meetup. I know Docker Captain Ajit. I know him, I met him quite a bit times, but over a period of time, Ajit has done great work into Docker world, and also like with other community members like Nipindra, Karan, and Vivek. So a lot of people. I think it's really glad to see everyone in the community, do more and more work around it. So that's about how I started in the community, and I blog at the specific place, and you can also always DM me at the Twitter. Now the key takeaways of this session. So what you would get if you would completely listen to this session. So I'll not bore you around. I'll try to go fast. And if you have any questions, stop me in between. Ask questions. I'm definitely looking at the chat window as we speak. So please ask questions, and then like we can go to that. So the key takeaways is running the Elastic Stack on Kubernetes. So Elastic Stack is an open source stack where there are multiple components, and each component does specific things. But the idea here is to how do you run this open source component on the stateful system on a Kubernetes kind of orchestration platform. Now, what is Elastic Stack? As you might be knowing, Elasticsearch is a search engine. It's a distributed NoSQL REST-based storage engine. And then you have Logstash and Beats, which are ingestion modules, which helps you to push data into Elasticsearch. It is also popularly, let me cover Kibana. So Kibana is a visualizer which sits on top of Elasticsearch. So people popularly call it as ELK, Elasticsearch, Logstash, and Kibana. Logstash is like your ETL, like your extract, transform, and load. If you have ever seen or heard about these tools, like maybe it's old now in the cloud era, but Informatica or Cognos, Ab Initio, these are the tools that people used to use in the BFSI world everywhere to shuffle data, to marshal data from one data warehousing place to another database, and to transform that in between. So Logstash is one such tool. You can also compare it with something like Talent. Beats is more of like a data shipper tool. It ships data out of your infrastructure and places to Elasticsearch, and thereby you can visualize it in Kibana. So another parallel that you could use is like you could also use Grafana with Elasticsearch. That is one another popular thing that people use. Grafana is another visualization tool which helps you to do that. But stack is this one. Whenever I say stack, this is the stack that I'm talking about. Over the period of time, Logstash is there, but then we have more and more things coming here, and which have come here. So Beats is the one that is like directly in working with more with Elasticsearch, and more new features have been rolled out. So that is one certain thing that I want to tell. So when people started using it, they first started with the search, because whenever it started using this platform, when Shai Bannon, our founder who built this product, whenever he started with this, he started with search engine. He thought of doing a receipt search engine for her wife, and then which got into this particular thing called Compass, which is also a GitHub project which is already there, but it's not distributed in large scale, etc. But later he did Elasticsearch, which is like a search engine. And then what happened is search was be the prime thing, and a lot many people use it to use search. For example, GitHub search is Elasticsearch, eBay search is Elasticsearch. You have several Indian startups like Swiggy, Zomato. Everyone uses when you're typing in the search bar, you are doing Elasticsearch. Similarly, like Netflix, help.netflix.com search is Elasticsearch. So there are many use cases where search itself takes away. But then there are other people who are in the DevOps community. There is a person named Jordan who wrote this Logstash, and he started using this logging, and then he pulled that logging logs from different places using the syslog server, etc. And he pulled the data, and he wrote Logstash, and then like he pushed into Elasticsearch, and thereby doing some sort of analytics on top of data. So that is how observability has come in. So which has logs, metrics, trace, APM, like distributed tracing, then uptime or synthetics, many other stuff, which comes under this larger envelope of like observability. And security being very latest and new use case, which is driven by the InfoSec community, wherein there is like all this SIEM, EDR, anti-malware, like your regular McAfee's and CrowdStrike does. They also have use cases like security incident analysis, threat hunting. So all of them come under security. So these are three prime use cases that we see when we talk to people. But then there are other use cases, where developer use cases, like business analytics, where people want to do analytics on the data that they have, like product analytics, telemetry, etc. Different sort of ML related applications, supply chain management, etc. So there are many things, but these are the prime things that if I have to tell you what are the use cases of the stack, these are the things. Now, who uses? Like a lot many people use, developers use it, DevOps professionals use it, then like I said, security professionals use it, like practitioners, people who does SOC. If you have ever seen the SOC command center in your organization, where there are analysts sitting on and looking at the security data, so SOC commands. There are also like for use cases like APM, the APM or tracing, etc. There are product owners, scrum masters, or people, product managers even. So they want to modify, improve the product, understand what sort of bugs that they are coming, how to ensure that engineering productivity is better. So that is another sort of users who use the stack actually. So deploying stack, it's a platform agnostic. As I said, it's an open source project. And then the stack, when I say stack, there are multiple software again, like Elasticsearch is one software, Kibana is different, Logstash, Beats, everything is different. So it is platform agnostic, cloud agnostic, as well as, operating system agnostic. You could also run it in Windows, which very less people do it. Most of them use Linux servers and deploy it on top of it, but most of it is supported, except for very few versions like, PowerPC architecture, which I believe some versions are supported as well, I think. So, but we are not talking about that part of the thing today. But what we are going to talk about, or more specifically mention about, is like, how do you run this particular stack like an orchestration, but like build a cloud service on Kubernetes, like build this stack and the solutions that we speak of till now. How do you build this using Kubernetes? using a Kubernetes platform. Kubernetes is a de facto and undisputed leader of container orchestration. We all know that. So how do we do that? So that's what we are gonna discuss about. So I believe that everyone know about Kubernetes, and if you don't want to cover this particular thing, I would skip that. So how many of you, I mean, like, have known the architecture of Kubernetes, or shall we go ahead and take a brief look about it? Question, people. You can write +1 in the chat. That's easy. Rather than if you want to talk about it. Yeah. If you know Kubernetes, write +1. Okay, so what I'll do is, like, because there is less people who are responding to it. So what I'll do is, like, I'll simply go and cover some of these things, and then maybe like we can come back and take more questions if you have. So when I looked at Kubernetes, it's around in 2015 when it started as an open source project in some Google meetup that somebody was talking about the pod selectors and and many other things. So, and I have literally no idea about how this would revolutionize or change things. And then even I don't know about Docker then in that old times. I only know about LXC containers, that too as a concept, but never thought of using it on my laptop. Never thought that it could be possible as well. So, so then, like, basically, Kubernetes is, like I said, is a container orchestration system, and then you have multiple nodes, and then you have pods which run these containers, and then these pods are deployed in multiple nodes. So that's how you have a distributed system, like different nodes, but also you have internal, again, distributed structure using the pods, etc. Then you have services, which is another decoupled mechanism here, so that through services you could access these pods, maintain and do a lot of these management around it. Orchestration around it, again, in a declarative way using YAML. We'll talk about that as well. You also have secrets, a secret store. You also have local volumes that you could attach, like you can attach like persistent volumes. There are different stuff like that. You could also attach network assisted storage in that area as well. So that is another useful thing to do it. But then I think around 1.12 or something, Kubernetes has announced something called stateful set, which allows them to run a stateful application, like application which shares states. For example, here Kubernetes itself is a distributed system, and it shares state using some specific thing that we are going to discuss here. But then how come something like if you take applications which are in distributed systems, like say, be it Redis, or be it Elasticsearch, or be it MongoDB, which is also a clustered application, or Hadoop, they share states, they share information in between their nodes, like between the container to container, they share the information. So how do you ensure that that system, that thing is good, and like how do you ensure that all of this happens properly? So stateful set is one great application to that particular thing, and which helps you to do all of this. And then later operator thing also has come, which has simplified it much better. So, like I said, it is a declarative way to do things. You have YAML and you have other resources. People write in YAML. Of course, it's confusing sometimes, indentation issues, etc. But YAML is a great way to define the schema and, like, deploy the applications and run this stuff. I'm not gonna spend more time here again. But architecture, like you say, you have a HCD cluster, which is like a key value store, and then you have API server, which manages your entire the state of this particular Kubernetes using by information from kubelets. And then you have the controllers. So you have multiple controllers, which based on that control logic loop, it will administer what to be done in the next state, etc. So this is the basic architecture. Like, I can go again, but I'll simply skip through. Like, etcd is there, API server which does things, user authenticates using HTTP or HTTPS, and then, like, uses kubectl, which is a CLI tool, or there are many other API based tools as well, like kubrick, etc. If I'm not wrong, there's the interesting tool which helps you to manage this as well. So then you also have kubelet, which runs in this pod like an agent, and then corresponds with the host and does all the stuff. Then the controllers are the things that we are going to dwell upon and then speak about sometime. So there are different controllers already in the Kubernetes, which is like which watches pods, assign them to a node, replication controllers, which make sure that replica set is at a certain amount of time, and cloud provider controllers like specifically around hardware infrastructure providers. Like say if you are thinking about AWS, they have a specific sort of hardware that you want to deploy. So the controllers which are specific around it. So different controllers does different things. So by this time you might be thinking, okay, I kind of know Kubernetes, and then I will probably like be able to deploy applications and do stuff. But I also have DevOps friends who say that Kubernetes is great, but if you deploy on a Friday, I will come and kill you. So don't deploy it on Friday, and things go wrong. I can't manage it, because if you are deploying something complex, if you are changing some things in production system, I can't manage it, and there is no great way to do it. So normal applications, yes, but there are complex applications which help you to which needs more things to be done, and that's also where things like Helm come into picture, wherein it does package management, just like npm, but more different than for the Kubernetes. It's more complex and different as well. So yeah, so more than Helm, I think operator framework is the one that changed this entire landscape in deploying the stateful applications or running your general purpose applications that you end of the day, all these Redis, MongoDB or Elasticsearch, or you take MySQL, PostgreSQL, or these applications still, but they are general purpose applications. You need a DB, you need a server, right? These are to be run, but there should not be a big problem around running those. These are run in the mill applications. You need to run it safely, easily. So operator framework, the SDK helps you to do this very easily. So yeah, I'll again quickly go through this. So Helm versus operator, one another important discussion that a lot many people might confuse. So Helm is like a package manager. It's it on a different level than you compare it with the operator. There are different types of different variations in the Helm explanation as well. But I kind of like found this very easy to understand. So if you see here where operator sits in and where Helm sits in, Helm still is in the every other way, and then operator is something below, wherein you still need to work very closely with the Kubernetes controllers and other ecosystem actually. So there is an operator hub site where you can find all these operators for different things. Of course, you could find the code of whatever the operator that I'm going to talk about here is Elastic Cloud on Kubernetes. There is a reason why we say cloud on Kubernetes. I'll also talk about that as well. Why it is cloud on Kubernetes, why it is not Elasticsearch on Kubernetes, etc. So talking more about it, so we have custom controllers which automate tasks like security, secrets, and several other stuff, what sort of deployments that you want to do. Suppose if you are looking at logging, if you're a DevOps professional and you're looking at log or in time series data, then you could look at things like different types of tenured policies, like say hot worm architecture, different types of architecture. So that is what we also do call it as deployment templates. You could deploy using the operator with that particular thing. So that's not it. I have the demo. So that's all the important content that we have. But I'll simply quickly go through the demo and then we'll talk. So any questions in between? So if you have any questions like in between, we can definitely talk about it. So please like unmute yourself and ask questions, and happy to answer.
Yeah, like hi. Yeah, there is one question. Basically, like, are there any prerequisites to get Elasticsearch up and running, like to configure the cluster or something?
Prerequisite as in?
Like, if you're configuring a cluster, like, are there some prerequisites on your system that should be there to configure the system, or it's like directly it's a package you can install it in?
Yeah, it's just a package. So that's what I'm going to talk about. That's the operator thing that I'm going to show about. So we haven't touched anything at this point. We didn't go to the site. We didn't download any package. We didn't do anything. So how are we going to deploy it? So if I am not wrong, so let me put it into a different place. And then like you see, I have created. I'll answer this question. Sorry, I didn't get your name, but then I'll answer this question, and then I'll show you something here, and then like we can probably discuss more about it. So let me quickly connect to the cluster that I have created here in GKE. Okay, so if I click wheel says authorize, yes, obviously, and it will generate and link to my this particular thing. If I say kubectl, I believe this is not visible to some of you. I hope this is visible, right?
Yeah.
Okay. So if you say kubectl pods, I believe it should say that no resources because there's nothing. I think so there is nothing available here. This is a plain simple vanilla cluster that I have created, and there's nothing here at this point of time. So I have this how to run this. I already have a blog post up and running. I have done this specific thing on AKS, Azure Kubernetes Service. We can simply use the same thing for downloading the application for downloading and running this. I'll just use this to copy my commands so that I don't type mistakes and we waste time on it. So what we're gonna do is here download this this particular YAML file which contains the descriptors and everything to run Elasticsearch. So we are not even giving any email ID, nothing. So it's just simply spinning up a Kubernetes cluster and installing this, and then this will create all these controllers that are there. You could also go and look at the logs that are generated, what sort of controllers, the controller logs that we have just put on. Say it shows that waiting to create this operator container, but it might take a while, but it will hopefully it will come out. So if you see here, we are creating some custom resource definition, a CRD, for called APM server, Elasticsearch, Kibana, and then several other things. Like if you have an enterprise search, even that will come in here. So let me see. Yeah. So now that the container is up, you could see the different controllers that are ready to listen the request from the user in the kubectl, and then take and spin up that particular stuff actually. Yeah. So what we'll do is like we'll spin up the Elasticsearch cluster. So let me see. I am using only one node here. I have 771, which is not the latest version. 791 is the latest version. I'm also adding a load balancer here. I'm adding a load balancer here, which adds an external IP. So I'm just using that as part of it. And I am also adding some settings like what sort of cluster it is, what is a node type, etc. So let me quickly click on this, and then it will automatically create this particular thing. So when I say custom resource definition in Kubernetes, what is the difference? So you might think like, okay, what is specifically different here? So it is like Kubernetes is now running Elasticsearch like a native component. Like if you see kubectl get Elasticsearch, we are talking to a custom resource definition which in the Kubernetes, which is specifically registered to see Elasticsearch as their own component. So that's why that's why it is driven this way. So let me go and see this. It will take a while to spin up this thing. You can also see that kubectl get pods W. It shows what status it is. It's in the unit level. But in the interest of time, I think while this happens, let us also look at the other stuff. So we'll also create a Kibana, and the good thing with this thing is like you'll be able to create an TLS based encryption, and then between the nodes, and then also you will be able to the cluster is by default secure, and it runs with the security, so you don't need to worry about external access even though you have attached a public IP. So I'm not going to look at the logs, etc. Anyway, you might be knowing it. But like I said, the password is there, so you could get the password from the Kubernetes key store, secret store. Like I said in the previous time, the Kubernetes key store, secret store, which help us to do this, store this credentials like this. Like I have this password generated, the username is Elastic here. So that is the default user that was generated, and then it is stored in the Kubernetes secret store. You could get by using kubectl command, this particular command. What I did is like stored in an environment variable that is present in this particular shell that I have. So I after which I could also like, I could curl this particular thing and which will show. Let me see if I could curl. But before that, so I have already created a cluster. If you see, it's already running. It also has a public ID. Now, if I want to, I already have the password, which is in the environment variable. I can just copy this external IP. And if I say the version is 7.7.1, and then the different variations. But remember, we have created 7.7.1, but 7.9.2 is the latest version. You can always pull the latest one, and build type is Docker. So basically, we already have docker.elastic.co where we build all the Docker repos and then push it everywhere in the Docker Hub and everywhere. So if you do Docker pull Elasticsearch, you are pulling a Docker Elasticsearch repo, the container. So what we have done is like using the same thing, you have an automation in place called operator, which helps you to do all easily. And there are different operators for even different stacks as well. So it is very popular in the Kubernetes world. So let me quickly deploy Kibana as well. So again, the same version. Remember your Elasticsearch in Kibana is if it is in same version, then it gives you, the better access, and it's on the same compatibility features as well. Again, you could do kubectl.get Kibana. Once it is deployed, kubectl get pods. Okay. Okay, it is container created. Let me run this again on the top so that you will see that. Yeah, it takes a while to create container, but it gets done. And then once you can access this particular, the Kibana dev tools, everything. But with again by securely logging into this thing. So let me quickly see if it is done. I don't know if it is in watch, but it might be taking a while. So we got the IP. The container has not been created, but let me go and say HTTPS IP, and then I say 5601. It should open Kibana. Okay. Meanwhile, it is not yet because the container is still creating. Yeah, it is running. It should open now. But I also want the password, right? Echo password. So in a minute, we created a cluster which has this particular the self-signed certificate, which has the security enabled, which is also running easily. So let me see if I'm doing a mistake here. Okay. 5601. Something is wrong. Maybe it came out, but I kind of 5601. Yeah. So if you see, it shares that your connection is not private and a lot of things. Like I said, we have security. How come this is coming? Because the certificate is self-signed. That's why cert authority invalid. So that's why it's saying it's invalid. But then when you click proceed, it will still show that you need to get in a use Let's Encrypt kind of a thing, and then get some certificate and attach to it. Right now, it is using self-signed certificate. So I could use Elastic and then click on it, and then automatically it will log in. But it didn't happen. Let me use it again. I might have copied the IP. That's why it is not working. Great. So if you see, I have logged into the Kibana. It shows me this the getting started experience, like explore on my own, or like show it like show the sample data. You could click on try sample data, but then you can go to explore on my own, and then you see the home page, and then other stuff here. We'll quickly go to the DevTools part of it, and we'll ingest some data. I hope there is a bit of time. Yeah, so if you have time limits, let me know. I think there's less time, but then if you have anything, like please ping me on the chat, and I'll take care of it. Like we can close this much faster. Okay, so what I'm trying to do is, right, I have a data set here, which is a national parks data of the US. So what I'm trying to do here is copy this data and create an index, and then we create a search engine here in Kubernetes using Elasticsearch on top of it. So what this data says is it's pretty simple. It's an index named national parks, and then you also have description, location, etc. So when you click yes, it will create the index and everything, and then we can simply go now and use the API to search this data. But what is fun to do that? So I we have an open source project again called Search UI, which helps you to do this easily. So let me see if I could spin that up here and then showcase that to you here in a easy manner. So let me come back here. So I have this project here called Search UI, and then which helps us to create this the search UI just as a friend to do this particular on top of it, and then helps you to create this. So let me cd the search UI examples Elasticsearch. So you could also like log into this and then to kind of like do that stuff. So it is an npm based project. So you need to install the specific the services or packages that are related to it. There are detailed examples on how to do that specific stuff. So if you click on this particular thing and copy paste this particular stuff, it tries to start like if I say npm start, it will not. It will say that okay, there are errors, but it let me see if I could do this for you. Yeah, every time it is creating this problem. Okay, so basically, what it does is, it spins up a search UI, and it helps you to create a search engine on top of the existing, the Elasticsearch data that we have ingested. So now that we have, now that we have the entire thing that is covered, you could do anything. You could deploy different applications like what do you call APM or search or anything. You could do all of that, and you could run as these as services, scale up, scale down, and do all of it. That's why we call it as Elastic Cloud, because we are building and essentially building an Elasticsearch as a service. So on Kubernetes again. So this is the UI that you would get. So you could follow the same steps that are mentioned in the document here, and then what you could do is like you could build this particular the entire uh, is simple React.js server, and then you could see this data in this manner. So I think we don't have time for doing all of this, but you could go and explore this by yourself. I have links already here so that you could go and look into that. Okay, so that's the end of the session, and I'm happy to take any questions if you have. Um, you know, I know that we
Yeah,
rushed through a lot of things, but if you have any
yeah.
questions, happy to ask. And these are the links for the resources for the session.